into our final paper. It's also is from the National University of Kaohsiung and Shooter University. The author is Professor Bao Rong Zhang and Xiu Fen Cai. Also include Qin Long Gu and Jin Wu Guo, Professor Jin Wu Guo. Today the presentation will be the Yao Kai Wang. The paper title is Intelligent Adaptation to in Cloud NoSQL Database Remote Backup Between Data Center. Let's welcome.
Hello. Good morning, everyone. And this is our outline. This paper implements data center remote backup using two remarkable NoSQL database, HBase and Cassandra. And this study performs performance stress tests with a large scale of data. For instance, read, write, and remote data center backup. In order to maintain data center backup over the internet smoothly, we propose an intelligent adaptation scheme. Adapted framework-based fuzzy interface in reference system together with particle reward optimization approach, which has employed for turning seamless handoff and control traffic flow between different data centers. And both designs in HBase and Cassandra achieve two of the three characteristics that are consistency, availability, and partition tolerance in CAP theory. HBase, a distributed database, works under the Master's Lab framework where the master node assigns data to the slave node to realize the distributed data storage. Meanwhile, the emphasizing on consistency and partition tolerance characteristics. HBase has the following advantage. Retain data consistency, activate instant reading or writing of massive information, access to large-scale unstructured data, expand unused slave nodes, provide computing resources, and prevent a single node failure problem in a cluster. Cassandra distributed database works under the peer-to-peer framework, where each node contains totally identical backup data to realize the distributed data storage with uninterrupted service. At the same time, emphasizing availability and partition tolerance characteristics. Cassandra has the following advantage. Each node shares equal information. Faster setup is quick and simple. Dynamically expands new nodes. Each node has the equal priority of its precedence, and the cluster do not have a single node failure problem. the H-based remote backup as shown in Figure 1. The master cluster and slave cluster both process its own independent zookeeper in a cluster. The master cluster will establish a copy code for the data center and the base name, the local location to the replication. So to achieve on-site or remote data center backup between different sites. In Cathedral remote backup as shown in Figure 2. So adjusting the replication mechanism between data center and nodes. The corresponding nodes are two independent data centers are connected and linked through SSH protocol. And then data have distributed and written into these nodes by master nodes or C nodes to achieve remote data center backup. And this is the Figure 1 remote H-based data center backup. And this is the Figure 2 remote Cassandra data center backup. Fifth, suppose multiple forms of RPC protocol acted as a cross-platform API. Fifth is also a transport tool suitable for large amounts of data exchange and storage. And comparing with JSON and XML, its performance and capability of large-scale data transfer is clearly superior and both of them. To both of them. In Figure 3, the input code is the programming language performed by the center, by the client. The device client is the client-side and server-side code framework defined by documents, and read-write our code outlined in grouped documents to realize actual data read and write operations. The rest are built transport framework protocols and underlying input-output protocols. Using scripts, we can conveniently define a multi-language device system and select different transport protocols. And this is the Figure 3 Apache script architecture. The server side includes the transport protocol and the basic framework, providing both single and multi-root operation modes on the server, where the server and the browser are capable of interoperability concurrently. The use of scripts to achieve cross-platform data transfer for either H-based or Cassandra in remote data center backup was in our proposed approach, and a system diagram as shown below in Figure 4 as well. And this is a Figure 4. In order to maintain the smooth remote backup over internet, we focus on the quality of devices, about the data transmission to receive. In other words, we have to deal with the also comments about jitter, loss, latency, and throughput. This paper introduced intelligent adaptation of turning data transmission and receive parameters priority in both data centers. Shown in figure 5, the diagram illustrates an intelligent adaptation using adaptive neural-based fuzzy inference system, along with particle swarm optimization approach, where DBWR and N denote the normalized CPU clock rate and size of SD-RAM, network bandwidth, and ratio of read-to-write operation, and the number of messages respectively, to adjust remote backup parameters and express. So the time interval of the message response between ration server and the master, as well as the ratio of read-to-write operation in system. It is noticed that PSO approach is utilized to search the optimal web and parameter in ANFISys. And this is the figure 5. Besides the same achieved of ANFIS is applied for turning remote backup parameters in Cassandra, namely the maximum size of command space in memory, the maximum throughput in read-write operation, and the percentage of cache release for saving the out of bound of Java heap, as shown in figure 6. Where every block, double block, is right, presents the numbers of read plus write operation instead of our read write in figure 5. And this is the figure 6. And those are the following procedures we propose in this study is to achieve remote backup operations. And the following formula will evaluate the performance index. In order to improve the quality devices on remote data center backup, we have to deal with the crucial problems about data loss, latency, and throughput in this experiment. According to the diagram as shown in figures 5 and 6, intelligent adaptation using an adaptive network-based fuzzy interface system with particle swarm optimization approach is employed and the result of intelligent adaptation to spy parameters and shown in figures 7 and 8. Data centers A and B have been installed a variety of databases such as the latest version of Apache HBase, Apache Cassandra, Cloudera HBase, DataStax, Cassandra, and Oracle MySQL. We are going to launch a series of the tests to measure their system performance and efficiency. Data center A and B perform the large amount of information writing tested through Swift, Java, and we calculate the average time to bring each time of a single button write for several databases as shown in figure 9. Data centers A and B perform large amount of information reading tests through Swift. We calculate the average time of a single button read for several databases as shown in figure 10. Searching for the latest version of Apache HBase and Apache Cassandra proposed in this study. Several benchmark remote backup methods, such as Cassandra HBase, DataStax, Cassandra, and Oracle MySQL, have also tested in the experiment, and the performance varies between the proposed approach and the others can show how the proposed one do very well in remote backup efficiency. The remote backup testing tool through Java and is mainly used to find out how long it takes to back up data each other remotely between data centers A and B. Calculate the average time of a single button backup for several databases between two distinctive data centers as shown in figure 11. So in table 3, we have found that Apache HBase and Apache Cassandra obtain high performance index, whereas MySQL get a low speed lowest one. NoSQL database has any better performance when based in massive database data processing. Security based on CAD theory in a remote data center backup approach based how to perform Apache Cassandra a lot because Apache Cassandra need to take a long time to follow the property of partition tolerance. Whereas in data writing test, Apache Cassandra is superior to Apache HBase because Apache HBase has to keep the property of availability to take a time-consuming work for the data replication between storage segments. This is the table 3. This paper realized the remote data backup for HBase and Cassandra data centers, and the performance evaluation for various database has been carried out according to the performance index. The approach proposed in paper has employed adaptive network-based file interface system, along with multiple swarm optimization applied to turn seamless analog to control network traffic below. The result HBase and Cassandra can best perform the RDRs. Provide that this paper indeed gives us an insight into how to evaluate the performance for the remote data center backup. And if you have any questions, you can write email to the Professor Long Zhang. And thanks for listening.
Okay, let's thanks for the I1 presentation. I think we already passed the time, so let's end this session. Okay, then we will go to the banquet hall, the second banquet hall, and the opening. Please do not miss in the opening. Thank you very much.